Have you been watching The Last Dance on Netflix, Mr. Minton?
Yeah, I have. That's that was my era. That was my team. I hated the Pistons. Love Jordan. Yeah, I'm obsessed with that show. I've watched a couple of the episodes twice. Yeah, it's so good.
That's awesome.
Yeah, it's the best thing I've seen since this COVID thing started. It's a heck of a lot better than that Tiger King crap we watched. I'll tell you that for free.
Yeah.
That was a train wreck, but I couldn't stop watching the darn thing.
Yeah, we'll live with that.
Yeah, no, I absolutely love it. I mean, when I grew up, I was a big basketball guy, especially in high school, towards the end. And man, I love Jordan and the Bulls. So yeah, it's been pretty awesome. Very awesome. There's no question who the greatest player is when you watch that show. He was so good.
Yeah, once you watch it, it's crazy. I kind of like,
Yeah.
don't believe it.
Yeah, you know what? It's great because people in your generation, I mean, everybody knows LeBron, and LeBron's legit for sure, but they don't realize how good Michael Jordan was. Like, he was on a different level than everybody for everything he did. So, yeah, it's been very, very awesome to watch for sure. All right, where are we at? 4, 5, 6. Okay, let's start with yesterday. Any issues with yesterday's work? No? Okay. All right, so today we're going to look at algebraically. So what I'm going to do is just go back through the two methods that we learned. So, and I'm doing this with the grade 10s right now as we speak. So the first method was what you were using yesterday, which is graphing. And that's to solve systems of linear equations, or systems of equations. 2 is substitution. And 3 is elimination. Okay, so I'm going to use the example on page 345. So they have y equals x squared minus x minus 6 and y equals x minus 3. So we have a linear. We have a linear and a quadratic equation, and we want to know the number of intersection points and where those intersection coordinates are. So the substitution method, this one's already set up for substitution method. It's actually set up for elimination as well. But for substitution method, you isolate one of your variables so that you can substitute it into the second equation. So basically what I'm going to do is I'm going to take this x minus 3 and substitute it in for y in the first equation. So I end up with x minus 3. There's my substitution. Equals x squared minus x minus 6. All right. Same thing as we've always done. Get it equal to 0. And that would be minus 3. Okay. So now I've got 0 equals x minus 3, x plus 1. X is equal to 3 and negative 1. All right, so we know that the intersection points are going to occur where x is equal to 3 and x is equal to negative 1. So now I'm going to take the second equation and find out what the y is in both cases. So I substitute that in, so that's 3 minus 3. It's equal to 0. So the first coordinate is 3 and 0. And I do it again. This time I substitute negative 1 in. On the second coordinate where they're going to intersect at is -1 and -4. Okay, so all I'm doing is I'm looking for, so just to kind of review it all, so I'm looking for two coordinates where the line is going to cross the parabola, and the two coordinates where they're going to intersect at are 3 and 0 and -1 and -4. And using the substitution method, I have my two equations. I isolate one of the variables. So they're both isolated in this case. So if y is equal to that and y is equal to that, then obviously these two have to be equal to each other. Okay? And so this is what we refer to as the substitution method. All right? So I will now use the same question. And again, this part of the methods, that part of the methods, they're the same for both methods. All right, so when I do elimination, I would go back to this and do it again. So the only difference between substitution and elimination is this step right here. So let's go to the elimination method. So in elimination, I have to line it up so that all right, so I line these up. Now, what I showed you last year is I want to make sure that I have the conjugate or the additive inverse here, so that when I add one of the variables together, it disappears. So what I'm going to do is first of all, I'm going to change the signs on the bottom one here. So I change all three signs, and then I'm going to add them together. And by changing the sign, I have now created y add -y, which is the additive inverse, and the additive inverse is equals 0. So I have gotten rid of my y there. Okay, so that's the important part. We want to get rid of the y or the x. Usually it's the y because I'm dealing with x squareds. So now I add the rest of this together. I get x squared minus 2x minus 3. And then everything falls into place the same way as it did before. Factor. I get -1 and 3. And then I substitute it into one of the two equations again. And I would end up with -1, -4, and 3 and 0. Okay, so I'm not going through that again. So that's the elimination method. So in the substitution method, just going to put them side by side so you can see the difference. The substitution method, I isolate one of my, so I make sure that they're the additive inverse of each other. So one's a positive, one's a negative, so that when I add them together, I get 0 for that value. Okay? So let's look at a different example now. Let's look at the first example because we have to rearrange it. So this is great. All right, so page 347, example 1. Equation A is all right, so there's equation A and equation B. So I have a quadratic function and I have a linear function. All right, so in the substitution method last year, I would say, because you were only working with lines, I would say you have to isolate one of the variables and then substitute it. So that you can do that again. So I would take B here and I would work with B. So I'm going to subtract 2x to this side. And then I'm going to multiply it by -1. So I get y is equal to 2x minus 2. Because I want to get y equals. I don't want to have a negative y. I just want it as y equals. So now that I have y equals here, so in B, y is equal to 2x minus 2, I can substitute that into A now for where I have y, and then I can solve it. So I'm going to go x squared minus x minus bracket 2x minus 2 equals 6. So I've substituted in 2x minus 2 in for y here. So that's the substitution. X squared minus x minus 2x add 2 equals 6. Collect all my like terms. X squared. So that's minus 3x. I subtract 6. That makes a negative 4 equals 0. And then I'm back to factoring again. X minus 4. X add 1 equals 0. X is equal to 4 and negative 1. Okay? So now that I have my x value, I need to solve and find out what the y value is of the coordinate, where they're going to intersect again. And again, I'm going to use the easiest one. So I'm going to use the linear one. So I go 2 times 4, subtract y equals 2. That gives me 8. Subtract 8 to this side, that's negative 6. Y is equal to 6. So, excuse me, that coordinate is 4 and 6. Okay, now I substitute in the negative 1. So I have negative 2 here. Add it to this side. Y equals negative 4. So my other coordinate is negative 1, negative 4. And again, this part right here and right here doesn't change for either method. You keep it consistent. You do the same thing for each method. The only thing that changes is how you go from these two equations down to whatever you're going to do right here to get it. So that's the substitution method. Okay. So again, we did this last year, but we did it with only with lines. We didn't use the quadratics for it. Okay. So are there any questions about the substitution method? I think most of you, go ahead. Okay. All right. So I'm going to do the same question again. This time I'm going to use the elimination method for it, and I think you'll find it a little bit simpler than what we did. Okay, so rewrite the equations again. So I've got a is equal to x squared minus x minus y equals 6, and b is 2x minus y equals 2. Sure. Okay. So for the elimination method, the best thing to do is to get everything, all the y's to one side and then the x's to another side. All right. So in equation A, I'm going to go minus y equals, and then I'm going to go minus x squared plus x plus 6, okay? And in B, I'm just going to add the y to this side and subtract the 2. So I'm going to end up with 2x minus 2 equals y. So that's for B right here. So what I did is I added the y to this side and I subtracted 2. Again, it doesn't matter as long as I'm consistent, okay? So now you'll see why I did that in a second here. So now I'm going to rewrite this equation up here as y equals, and then I'm going to have 2x minus 2 right here. Okay? So what I've done then, okay, what I've done here is I've made it so that I have a negative y in A and a positive y in B. So now when I add them together, I get 0 there. Add everything else, so minus x squared plus 3x plus 4. Personally, I don't like to work with negative x squareds when it comes to factoring. So I'm going to times everything by -1. And I'm back to where I was at the last one. So the big thing about the elimination is, number one, rewrite the equations where you have y on one side and the x's on the other side. That helps. And number two is make it so that one of the y's is negative. So if you have to multiply everything by a -1, then do it just so that they cancel out when you add them together. So then back to this right here, which is x minus 4, x add 1, x equals 4 and -1. And then I have to go back through this process again to get my y values. So again, it's how you go from here to here. And in this case, I went from these two guys here down to there. So that's either a substitution or you rewrite it out and you do an elimination with it, whichever works. Okay, so let's have a look at example 2 then on page 348. So equation A now, these questions can be a little more work. They're not difficult, they can be a little more work. So what I try and do is right away early is I play around with the question and I rewrite the equation out to save a step or two. So for example, the first equation is 3x squared minus 24x minus y equals -52. Well, I'm going to move the y to the right side and I'll move the 52 over to the other side. So what I'm going to end up with, if I rewrite that equation, and again, I'm just setting it up so it's easier for myself, I'm going to end up with y equals 3x squared minus 24x plus 52. So again, it's not the same as the book. The book has a -y in there. Well, I added y to the other side, and I added 52, and I rewrote it. Okay? To me, that's just saving 1 or 2 steps along the way. And equation B now, I see equation B has a -y. So now what I'm going to do is I'm going to move -2x squared, 16x, and -28 all to the right side. So that's going to give me 2x squared minus 16x plus 28. So now I've moved them all to the right side of the equation. So now at this point, I can add them minus 40x plus 80. So in one, just by arranging them differently, getting them lined up nicely, I have a quick and easy way of getting this right into my factoring. Now, because I'm solving, I can simply divide by 5. What is that? One, do the math. Draw a blank here. So that's 40, that's 16. Sorry. Okay, so I have that. All right. So I have 2 quadratic equations, and I want to find out their intersection point without graphing. So I've decided I'm going to use the elimination method. And now I've got it to the point where I can factor this. So I get x equal 4. Go ahead, Amber.
Once you factor out the 5, you just you don't have to keep it anywhere within the question.
That's correct. Because it's a solving question, because it's an equals to, and I can divide it out by 0, All right, I can go 0 divided by 5. I can divide it and get rid of it. Now, if I was asking you just to simply factor, you would have to keep it as part of your solution. Okay, but because it's equals, I can get rid of it. All right, and you'll notice I only have one solution now, which means then that I'm talking about the vertex for both of those two equations. So now I substitute in 4 into one of these equations. So I go y equals 3, 4 squared, minus 24 times 4 plus 52. Y is equal to. So I got 4 squared, so 16. So that's 48 minus 96 plus 52. So 48 and 52 make 100. 100 subtract 96 is 4. 4 and 4. And what I would find is if I found the vertex for both of those equations, if I found the vertex for them, I would end up with 4 and 4. So there is only one intersection point for both of those equations. Okay? Now remember, there is a possibility that you have 0 solutions in these questions. Okay? They may not intersect. Depending on where they're drawn and where their vertices are, they may not intersect. So that is a possibility that you're looking at when you're solving these. You may not come up with a solution. For example, the factoring part here may not work, and then you try your quadratic equation. And when your quadratic equation, you'd find out you'd get a square root of a negative number. You wouldn't get an actual root for it. So I have that. Okay? So you notice, again, also I used the elimination method. The elimination method to me was the easiest way to do this question. Okay? All right, I'll look at the word problem here. It says 2 golfers are practicing their swing at a driving range. Each hits a ball at the same time. The path of the first can be modeled by the equation y plus 27 equals negative 5x squared plus 40x. The second ball can be modeled by the equation y plus 8x squared equals 40x. In each equation, y is the height above the ground in meters after x seconds. Determine and interpret the solution of the question. So basically what we're doing is player number 1 hits a ball here, has that kind of trajectory. Player number 2 hits it at the same time, and we're trying to figure out, you know, is there an intersection point between those two, the path of those 2 balls? We don't know, so that's what we're trying to figure out. And they're both parabolas, so we could graph them, but because we're practicing, we're going to use one of the 2 methods. Again, the easiest way to do these questions, is to set it up right away in y equals form, if you can do that. So the first one, A, is now going to be y equals minus 5x squared plus 40x minus 27. And the B one is going to be y equals negative 8x squared plus 40x. All right. Okay, so now I have it set up. If I wanted to multiply these by -1, I could and add them. That's the elimination method. But because they're both in y equals form, I'm just going to simply let the 2 equations equal each other, and I'm going to solve it that way. So this is the substitution method. So you can see I can jump back and forth between the 2 methods. And I can use, and in word problems, I can use either one. It doesn't matter, whatever works. All right? So I'm going to go minus 8x squared plus 40x equals minus 5x squared plus 40x subtract 27. get everything to one side. 0 equals 3x squared. And that's minus 27. All right, I added 8x squared. I subtracted 40x. That canceled those guys out. And I'm left with 3x squared subtract 27. Rule number 1 of factoring, take out the greatest common factor. So let's divide by 3. 0 equals x squared. X equals 3 and negative 3. And one thing that we know is we're talking about time, so that can't be a negative value. All right, so I've got x equals 3. So I'm going to use one of the two equations. I'll use equation B. Y equals minus 8 times 3 squared, add 40 times 3. 3 squared is 9. 9 times negative 8 is negative 72 plus 120. So I take 120 and I subtract 72, and I end up with 48. So after 3 seconds, those two graphs, or those two golf balls, are going to hit at 48, meters above the ground. Okay? Now, I didn't say this before, so I'm going to say it now. Check your answer by graphing it. You have the technology with you. Check your answer by graphing that. So using the technology. So let's have a look here. All right, I'm going to punch those two equations into my graphing technology. Sorry, I'm just going to change my grid range. There we go. Put the second equation in. And voila. So I'm looking at two parabolas now. Okay. Now it says that they were hit at the same time, but you see that the graph doesn't start at the same time, according to that. But they do intersect right here. And that intersecting point is 3 and 48. Oh, sorry, it's really hard for you to see. I don't know if that helps or not, but so 3 and 48 is right here, the one intersection point that they connect at. Now, remember our solution said that it also hit at negative 3, which would have been down here somewhere. Way down on the bottom of the graph. But we don't worry about it because we can't have a negative time. So there's my solution. So I've checked my answer and I'm pretty sure I got it right. Okay? All right, so that's the elimination and substitution method. So for tomorrow, if you could get to the end of question 4 again, that would be ideal. Okay, so that's page 350 to page 354. If you got 1 to 4 done, that would be, well, 1 to 6, and then you're actually done. So try and get the first 2 questions done for tomorrow. So 1 A, B, C, D, and 2 A, B, C, D. That's more than enough for today. Okay? Any questions about either method or anything you did yesterday? Any questions in general?
Do you think we'll have an assignment this week for this chapter?
Yeah, what's today, Wednesday? Yeah, I could see one for Friday, but I might leave it till Monday too. We can.
Yeah, because they're gonna be done soon, probably.
Yeah, we are ahead of the game, and I will go back. My plan is if we do get done somewhat early, I want to spend some time going back, and because of the way we've done things, I want to make sure that I'm going to go back and make sure that the key elements to this course, what I'll do is I'll probably run mini assignments after it's all done on each section. We'll do like a chapter. We'll pick sections, and I'll just do mini assignments, like a couple questions a day to hand in, and so that we can kind of revamp and rehash what we've done already. That's what I'm looking at anyways. All right. Any other questions, concerns, anything from 8.1 or 8.2 today? Okay, I'll leave you up and running for another 20 minutes or so, 15, 20 minutes. If you have anything, just ask. I'm just going to be messing around in my room here trying to do some marking. So, yeah, I'll put myself on mute. I'm still here listening. Just heads up. And, yeah, if you have any questions, just ask. All right?